Alright, so what we're going to go over in this lecture is an introduction to R. This is not necessarily a comprehensive introduction, but it's a good place to get started on understanding the basic components to R and what some of the things are that are going on in the background so that you can process better how to use the program in the way that you're interested in using it. So I am not an expert, but I will tell you a little bit about R. And so definitely not an expert. I've been learning R for over a year now, and it does have a very high learning curve, and it will be very frustrating at times. And there will be errors that you will get that will not make any damn sense, and then Googling them will not help. So I just generally tell you to find an R friend that can help you with some of your problems, learn how to Google better, talk about that in a minute, and don't give up. So generally how I learned R was I needed it to do a project that SPSS wouldn't do. So by the way, 66,000 lines of a multi-level model is not something SPSS will do. And so what I did was I found some code that people had used and edited it to work for me. And I think that's a really great way to learn all types of all types of programming skills. But it does help if you have a good base and you understand what the different object types are to be able to apply those skills to different functions. So one of the big things I'm going to cover in this lecture is object types. And once I really had a good overview of those, I think it really helped solidify for me what was going on in a lot of these functions in the background and why I was getting some of the errors I did. So that's really what this is meant to do. If you already know R, this may help you get a more solid base to work from. Okay? So you will get frustrated and you will get errors, but it's okay. We'll survive. Okay? So once that happens, I tell you that Google is your friend. Try Googling the very specific error message first. That doesn't always work because often the error message includes the variable names that cause the error, and so other people aren't going to be using the same variable names you are unless you're taking a class, clearly, and so that may or may not be useful for you. If you get the NaN error, it's not a number, that won't necessarily be anything good to Google because it's caused by lots of different factors. So the error is correct. It is that you got something that wasn't a number. You tried to divide by 0 or infinity, or you had some problems with missing values, but it's not a helpful error because you're not sure why you got to that point. So I tell you to Google the function you're looking for and the error, but take out your variable names. Maybe put stars next to them or something, because then you'll get other people who've gotten the same error with that specific function. So try a bunch of different search terms to try and get where you've gotten stuck. And so really doing it with the function that you're working on, like linear modeling, so LM, will help you get to an answer for your problem. So a couple of quick websites that are really great. So QuickR is a place that has a bunch of examples of how to do simple things like t-tests, ANOVAs, and plots. I use it a lot. So it's a really great resource. R documentation is not necessarily the best resource for learning R, but if you're looking for something in particular, it will tell you what packages might include those functions. So once you get kind of rolling with R documentation can show you maybe which packages do graded response models for IRT. Google will also do that, but R documentation is a place that kind of compiles all of that. TryR is a free website that lets you try R within the browser, so you don't even have to have the program or any of the other programs I'm going to talk about in this lecture. And so it's run by Code School, and it's really cute. They give you badges, and it's pretty user-friendly. Swirl is built into R as a package you install that is built in tutorials. I like Swirl a lot, but there are times it's very frustrating because of the way it expects you to go through the tutorials. So what I always tell people is you get stuck on Swirl, you can type skip to skip the answer, or you can Google it because all the answers are online. Now, that doesn't help if you're trying to learn, or if you are taking it for a course. Don't do that because that's cheating. But if you're getting stuck on like exactly the way it wants you to type a particular thing, that can solve some of your issues. The other website is Stack Overflow. Stack Overflow is a programming site where people ask questions. They're not always the nicest people, but they often have really great answers. So you can ask questions and get answers. I mostly just Google looking for someone who's asked a similar question and get an answer from them. Okay, so Stack Overflow is a great website if you have questions about other programs as well, like Perl or Python, C++. Textbooks-wise, I recommend the Andy Field. This is really based on someone who's trying to learn R to do statistics, because that's where my interests lie. But his books are funny, so they keep you interested. They talk a lot about theory and then statistics, and then how to run the statistics and how to talk about the statistics. So it really presents you a nice, complete picture of research methods. He's a child psychologist, so it's really from a psych point of view, but that can apply to the other social sciences. And it is a monster book, but it is a great book. If you want something free, Daniel Navarro's Learning Statistics in R is meant for someone who knows a little bit of stats and SPSS, but no longer has access to SPSS. That book is free online, and his website actually has a bunch of tutorials on how to do things in R. And so I actually tell you to go watch his tutorials as well, especially if you're struggling to learn. His are more complete, a good picture. So both of those resources are great. Dan Navarro's stuff is free on his website. So first thing you have to do is actually download R. And their website is a little confusing sometimes, but generally you just kind of click around till you see. So if you're on a Mac, what you're going to do is go and get the package. If you're on Windows, it's called a binary, I think. So let's see if we can get there. I'll show you what I'm talking about. Okay, or their website could be down. There it goes. All right, so CRAN is the Comprehensive R Archive Network, I think is in. And so they're the people who run and control the language of R. And so when they update the actual program, these are the people who do it. And then packages that have been approved go through these people. So if you're on Mac, which is what I'm on, you click on that and then download here. So that's R 3.2.2 package. You can download the older packages, but generally if you have a newer Mac, I would tell you to download this one. If you're on Windows, what you do apparently is wait a while. Okay, well if you're on Windows, once it loads, what'll happen is there's a link over here that says install for the first time. There it is. All right, so this is kind of confusing people, but what you want to do is just click here, install R for the first time. And then once you get that downloaded, you will install R, and then my recommendation is to actually never open the program. And so what we're going to do, and what I would suggest to most users, is to use RStudio. It is fantastic. I love the hell out of it, and I'll show you how it works here in a minute. If you are on a Mac, you will often need Quartz. Quartz is a separate little program that will help make the plots in R, and sometimes it's called X11. Generally it's called Quartz, and often the first time you try to use the plot function, it's like, hey, you don't have this, you should install it. So it does kind of warn you that you don't have something you need. So this is R. I had an older version when I did this, so they name all the versions of R, and they're funny. So 321 was World Famous Astronaut. And so this is all that R technically is. And so these are only the little options that you get up here, and none of them honestly are very helpful. They look like they do things, cool things, but they don't actually do what you expect them to do. And then this is the workspace for R. So I would recommend not using it. Instead, what we're going to use is RStudio. And so I jokingly say it's for the love of sanity. But if you are going to download Studio, their website's a bit fancier. And it's much quicker, apparently. Don't download Shiny, use Studio here. So click Download RStudio. And then you want RStudio Desktop, because you're an individual user. And then you would click Download RStudio Desktop. You would go through and install that program completely as well. And this is more of what RStudio looks like. And so it uses R to run. It runs R in the background for you, and it's a really great overlay that helps you run R and makes things a little easier. It's also a little bit more visual for folks who aren't used to programming and remembering everything in their head. And so I'm going to walk through Studio, but I actually have it open too. And so, see, like I said, I have R321. I don't know that it's necessary to update packages or the R version that often, but definitely if they start, your numbers are very different. So if you have 1.2 or something, you got to start over. But I usually try to make sure I update every time they update at the second decimal. So once 3.3 hits, I'll update that. But not totally essential to have the exact same type of R. If you are getting differences between you and someone else running it, that's a good thing to check, is make sure you're running the same version of R. Alright, so I'm going to talk about Studio here. Now I took these screenshots, and they might be slightly different than your version of Studio, but it should run the same way. Okay. So the top left window in Studio is the scripting window. These are files that end with a .r extension, and this is syntax. So this is where you're going to write your code to save to be able to run later. You can also write code, we'll talk about commands here in a minute, in the R window. But if you're wanting to save this code to be able to run at another time, this is where you do it. There are other programs that will let you write the scripts, like if you're on Mac. A really great free piece of software is Text Wrangler. It's by Bare Bones. If you're on Windows, Notepad++, there's a bunch. Those are just two free ones that are really great. But the scripting window, I have mine set to black and white because I can read that better. It comes up, I think, automatically as white and black. But it changes colors based on what you're typing. So that's really nice because it allows you to see that you're typing something, like it changes based on what you're typing. The other cool thing that Studio does now is often if you have forgotten to close a parentheses or it knows something is wrong with the line, it puts a little stop sign with an X over here on the particular line where it's broken. It's not perfect, but it's actually a really nice feature of Studio. Okay. So this is where I can save it, you can search it, you can run from here, get to that in a second. But this is like the scripting window itself. Okay. Now the save icon that's right here, mine's not lit up, but right there is the one where you'll save the script. This save icon up here is one where you would save the environment. I'll come back to that idea in a little bit, but essentially here is where I would save the script that I'm working on. Here is where I would save like the entire shebang that's open. You can also do that here. But be sure you're using this little one to save the script you're working on. Alright, let me go back. So first window is the scripting window. The top right window is the environment window. Now most computing people think about environment as the things you have open. So think about it as your desk. It is the things that you have currently, or your screen on your computer if you want, open. So an environment is things that I have that I could use at any given time. So like for example on my desk I have the Andy Field book, I have my keyboard and stuff, so these are things that I could use to work with in R. Or if you're looking at my computer screen, I have PowerPoint and RStudio open. Okay. Not perfect, but it's kind of an idea of what I have open. This is where you'll have specific variables that are open, so that's a little bit of what these things are. It's where you would have data that might be open, or script functions that you've written for that day, so to speak. The other cool thing about this window is this import dataset option. So that'll let you import a CSV file, and then the clear option here. On the newer versions of Studio, there's no word clear, it's just a little broom. And clear will let you clear out the environment. So if you're wanting to work on a different project and you don't want a whole bunch of variables in there, you can clear them out. The import dataset option I'll go over here in a little bit. The bottom left window is R. So I showed you a couple slides ago that if you just opened R and only downloaded that, this is what it would be. So Studio opens R for you and then has several other windows to help you out. So that's cool. So you have it open. And so this is where all the magic happens. So this is the area where the math behind the scenes is happening. This is where scripts get run. So typing them in the top left-hand window, the scripting window, doesn't actually run anything. It's just a place for you to save your scripts. This is where you will actually run the script. And in general, this is like where everything happens. The other windows are to help you know what you can do to make things happen. The bottom right-hand window is kind of neat because it allows you to do a bunch of different things. So clearly it has plots. Let me go back over here to Studio. So I can look at the file. So this will tell me where I'm currently working. We'll get to working directories again in a second. I could look and make a specific plot and export that plot. It shows me all the packages I have installed. So these are all the like plugins for your browser, all the different things I could use to run whatever code I'm interested in. The help window is probably my favorite feature. Sometimes help documents are not as useful as you would like them to be, but, so you can make these bigger. This is where you would get help on something. So if you weren't sure what type of NA action, so NA action is what do I do with missing values, I can look up a specific function. So I can search here. So let's say I wanted to search for LM, which is a linear model, it's regression functions. And I can look at what the LM function does, all the details, and usually at the very bottom some examples of that function. Sometimes these are really well documented and they're super helpful, sometimes they're not. Just depends. The other cool thing it does is it tells you what package it's in. And so that's helpful. Let's say if you're trying to use a function that's in a package you don't have open, it will not actually let you open it. So you have to, sometimes this will let you know like, oh, I don't have that open, so it won't run. All right, so that's what Studio looks like. And hopefully a lot more of those words will make sense here in a minute. The other thing I'm going to recommend you use is R Commander. It's talked about in the Andy Field book. And I was reading on someone's website generally that R Commander is the way to limp along until you learn R. And I thought that was a really great description of R Commander. It is a GUI interface, so graphical user interface, that allows you to, it's not SPSS or Minitab or any of those other programs, but it's a way to sort of do point and click actions in R, and then it'll actually show you the code that it's done. And so I really like it because it allows me as an instructor to say, okay, click this, now let's look at the code and see what the code does. So I think it's a good way to try to do some things and then see what the code looks like, so you can slowly kind of take in R, but it not be super overwhelming. So that is a package you can install. It's like an add-on to R, and Studio is a program that runs R and will let you handle packages. All right. So all that being said, let's get into like what actually happens in R. And so one of the first things are commands. So commands are the code that tells R what to do. If you're familiar with any other language, this is the script. This is where you write the code out. If you're used to using MATLAB or Python, this is like where the action happens. So commands range from being very, very simple, we'll do some simple ones, to extremely complex. And so my sort of side note is R only does what you tell it to do. I, believe me, have been frustrated so many times with like, that is not what I meant. Like, I wanted you to do this, why did you do that? And that's generally a coding error. So there are two types of errors. There are like straight typos, like errors in coding where it will not run because you've typed something incorrectly or that's not the way that function works. But then there are also errors, which are generally called semantic errors, where you've typed everything correctly. Like code is runnable, but it's not what you wanted. So the error to me is much harder to figure out what you've done incorrectly because it ran and it looks like it did something appropriate, but maybe you switched X and Y. So that's a common mistake to make when you're starting, is to list X and Y in the wrong order. And so you ran the code because it doesn't care if you switch X and Y, but it's not what you wanted. So there are two places to type commands. You can do in the syntax, the scripting window, or directly into the console. They both have the same effect. The cool thing about typing them in the scripting window is you can save it for later. If you type it in the console, you can't. So let's try something really simple. So let's do x equals 4. Okay. So I'm going to go over here to Studio, and I'm going to make my help window kind of small over here so we can really get into scripts. I'm also going to blow this up into a usable font size. All right, so I could type in the scripting window here and say x equals 4. So what I'm doing there is I'm setting a variable, x, equal to a number, 4. And so that will allow me to save that number for later. Now, that didn't do anything. Okay? That just allowed me to type. So let me make this actually just a little bit more this way. So what I could do is, if your cursor is on a specific line, you can just hit run here, and that will run it. So what happened when I clicked run is it moved down to the next line because it ran this one, so I'm going to move on. And then it also, down here, ran x equals 4. Okay. I could have also just typed x equals 4 down here. Now, what is this little caret thing? So the little greater than sign down here is R's way to denote, I'm ready, let's do something. So what do you want me to do today? And so this little icon here is where it's waiting for a command from you. If you accidentally hit enter or type something that isn't complete, you will get a little plus symbol. The little plus symbol right down here indicates that you aren't done. That line is not through. So I'm waiting for you to finish. Okay? And that can be very frustrating because a lot of times it means you haven't closed your parentheses that you should have closed and you can't figure out what you did wrong. Okay? So then I can type 4 and hit enter, and now I've got the little caret icon again. Okay? What else did that do by typing it in any one particular place? Let me do y equals 6 real quick. Look over here. So over here in this global environment area now, it's told me that I have x equals 4 and y equals 6. So that has saved the values for me and told me what they were. Okay, so these are very simple vectors, 1 by 1 vectors. And so it says x equals 4 and y equals 6. So if I type just x down here in the console window, hit enter, R will spit back out that it's the number 4. So it told me, hey, there's one number and it's 4. You could also just type x up here and tell it to run. It would do the same thing. Now, if you're on a Mac, if you hit command, let me try this real quick. Yeah, command and return at the same time. Command is the old Apple key. And enter at the same time. It will run the line you're on. If you're on Windows, I think it's control enter. And then, or maybe Control R, I think both work. I don't think Command R does not work in Studio on a Mac, so it's Command Enter. So let me go back here. Right, so we have finished this slide. Let's move on. So capitalization does matter, and it will show you the value or values of x. Okay, so what is this little 1 number here? It says give me a minute, but I'll go ahead and explain it to you. But what that means is that there's one item stored in that value. So x could be multiple items. X could be 2, 4, 6, 8. And so it would show you all of those. and it has to have a way to denote what that item is. So when we get to subsetting here in a little bit, it's going to be really important for each item to have a marker, to have an indicator. You can think about it as a barcode or a serial number. And so this little square bracket thing is just a marker of like what number that is. So there's only one item, so 4 is the one item. Now a lot of programming languages, the first item is 0. Okay, that's actually really common, not in this language. The first item is always listed as 1. Okay, so if you're used to programming in other languages like I am, don't get confused there. So the first item is always 1, not 0. All right, so a quick note, when you say that something is equal to something or this set of symbols, those two things are equivalent. So let me go back to Studio here and show you where I have x equals 4 in this function. So I'm going to hit Command Enter. It ran just fine. So these line 1 and line 3 here are equivalent. R understands the equal symbol and this symbol. This, I believe, is left over from the days where equal stood for something else in a programming language, and so it's also very visual. Like I am setting 4 to be equal to this number. I don't know that people use this sort of thing a whole lot anymore, but they are equivalent. If you are taking the swirl tutorials, you have to use this. Okay? And I feel like the big difference between people who use the equal symbol versus the other sets of symbols here are really more like computing. So people who are used to doing computing type functions are going to do it this way. People who are used to, like me, just doing statistics are going to do it this way. Alright, now that we've answered all the ringing phones and door knockings, let's get back into this idea of commands. So we ended with talking about how you have to use swirl. If you're using swirl, you have to use the little lesson sign and the dash to get credit, but remember the equal sign is equivalent. And so moving on, I'm thinking the important thing to ask yourself in R is not can R do something, it's how can it do something. And fortunate and unfortunately, the answer is about 10 different ways. So in a lot of these demonstrations, I'm going to show you several different ways, and it's really whichever one makes the most sense to you. Like what works for you? What are you understanding? And do it that way. There are times where it will be, this is the way you should do it, end of story, but generally, especially in statistics, the answer is, well, you should probably do it this way, but there are lots of different ways to achieve that goal. So in R, there are going to be a lot of ways to do the same type of analysis. There are about 10 different ANOVA packages alone. So, thinking about commands, we've talked about commands in the bottom window, and now let's talk about the scripting window. And if I type in the scripting window, nothing happens. So what will happen is if I type x equals 4 and then hit enter, before that did something. So I would get some numbers down here in the workspace or up here in the global environment. And so the scripting window, the only thing it does is it lets you save your code. Okay? So it's a way to keep your code for the next time you open R, because the console window does not get saved. Okay? So the scripting window allows you to save on code without running it, or you could run it. Okay? So I can run that code by either highlighting it or making sure my cursor is on the line that I want to run. And so in Windows, that's Control R or Control and Enter. So let me add that real quick. Right, both of those work. And on a Mac, it's only the command, which used to be the Apple key, plus return. And on newer versions of Macs, it says return and enter on there. So it's basically Control Enter or Command Enter. Or you can click on Run, like I showed you here. So let me show you. Okay. So if I'm highlighted on the line, so my cursor is blinking on line 1, I'm on a Mac, so I'm going to hit Command Return. And what you'll see is that dropped my x equals 4 down here into the console and also added it over here to values. So it's been run now. If it's down here in the R window or the console window, it's happened. R has done something. But just because you type it up here and hit enter, that does not mean it did anything. So the confusing part to people at first, when they first start working in Studio, I think, is that down here, if I type something and hit enter, it does something. But up here, it doesn't. Well, that's because this is a text editor. It's letting you save your document. Okay, so to run something, you can hit Command Return on the line you're on. Or let's say you want to run multiple lines at a time. You can highlight them, do the same thing, or highlight them and click Run. Okay. I tend to use the text option because I'm typing as I go. It's a little faster for me, but you can always click Run. And Run will run the current line or the entire highlighted piece for you. And by run, I mean it drops it down into the console window or the R window and makes it happen. So R processes it. Let's get down. So the scripting window is really fantastic for you for several reasons. So it's a way to save the projects that you're working on so you can recreate them later. So a lot of times, at least in psychology, what will happen is you'll run something, you'll write it up, you send it to a journal. 6 months, maybe a year, maybe a year and a half later, they'll come back and they say, you need to fix these things. If you haven't kept good notes or you haven't kept lots of different files, if you're using SPSS, you may not remember exactly what you did. And that happens a lot, at least in our lab. And so what you can do is in the script, you can leave yourself notes. So there are ways to make comments. That's the pound symbol over the 3 or the hashtag symbol for you youngins. So those are notes that I can make within my document. Here's what I'm doing and reminding myself why I did it. Like this is analysis 1. Okay, this is the ANOVA between these groups. And when you run anything that's got a pound symbol in the front or the number symbol, it doesn't do anything. R ignores those. It just sort of shows you like, hey, here's the line you wanted. I'm not going to do anything because it's a comment. So it's a way to make notes in your code. And so you can recreate all those steps and all those files later. So when I taught statistics in SPSS, and really when we were talking about data screening, I spent a lot of time talking about save different files. I've got a master file, I've got a an accuracy fixed file, I've got a no missing file, an outliers file. So you could really see what you had done to the data set, because when you save a file in SPSS, it's permanent. You can't go back and add those participants later unless you have the previous data set. And now, what you can do is you can load the master file. So you'll have the master file saved on your computer, and you'll have your syntax or your script saved, and you never actually edit the file, the master file itself. You're editing the working file that R is creating on the fly. So I can have one script file and one file, and that saves me so much room on my computer. I don't have to save multiple files. I can just recreate those files every single time. Now, one word of warning is that if you're going to do any missing analyses and you use a library like mice, those do impute missing data differently every single time, with a caveat about setting a start seed, which we'll get to when we talk about missing data. But generally, you'll be able to save and rerun it in the exact same way, which is really helpful if you're trying to recreate an analysis for a journal or your advisor, or just to see what you did and try to remember what the notes were, that sort of thing. So this is one of the reasons why I really like R, is because it saves me room on my computer, one, and I can recreate these data sets on the fly when I need to. So 2 sort of console shortcuts that are helpful if you're working and you've done a lot of work at once. And that is, at Studio here, if you are in the console window, so remember that's down here, and you hit the up arrow on your keyboard, it will scroll you through the last couple of things that you've typed. Okay, so apparently at some point I had typed view cheese in one of the previous openings that I had of Studio. And so it will let me scroll through and retype something. And maybe I can go back in and say edit it. Okay. And that's really handy. The other thing that's super handy, let me create you a variable first that's kind of got a long name. Okay, so I created a vector of data. If I start typing that variable name and I hit tab, it will fill in the rest of the name for me. So that's really handy as well. And that will only work if it's a perfect one-to-one match. And so it might, if you hit tab, give you several options. One of the other cool things that Studio does is if you start typing a function, it will give you options to fill in those functions. So if I said I wanted to open a data set, which is the data function, and I know I want to use air quality, it's like slowly cycling out the things that match. So I can hit enter here, and I could load that data set. Okay. So Studio does some of these cool fill-in things for you. That's what that's doing. R doesn't do that. R does the tab thing. So if I started typing data, I started typing air quality, I could pick one of the options here. Okay. I didn't like that actually. But so a list of variable names with the tab key. Okay, so I think I've probably convinced you that Studio is the best thing since sliced bread, but if you aren't convinced, why Studio? Well, SPSS is visual, so is Minitab and Excel, and SAS sometimes, but R isn't. R is not meant to be a visual editor. You can view the things that you're doing, but if you can't remember the variable names, it can be pretty daunting. And the first time I tried to learn R in R, I was like, oh my god, why? And so this is where the environment window really is helpful. So anytime I create a variable, it's going to appear up here in this environment window. So I've got x equals 4 in this particular picture, but looking at my environment now, I've got several different things going on. They're all listed under values. I'll get into what are the different types of values here in a minute. Okay, so this is all still under commands. Right. So the environment window really lets me see what I have open. So it's kind of the things that you have open on your desk. I think I explained earlier in this video. But it's really like, here are the things I can use and manipulate, with the caveat that some things are hidden from you in R that you can still use. But generally, it's the things that you've created and you've made and you can use in another analysis. That is super handy for some variable types called lists and data frames. Especially if you are unfamiliar with the functions that you're using. So the first couple times you use it, you can look through at what it stores. So think of a list. This isn't a perfect analogy, but think of it as saving the output in SPSS. And so you're going to have a whole bunch of different types of things. So the good thing about lists is they store different types of objects, and then you can call them one at a time. So generally when you're working in, I pick on SPSS because it's what a lot of people are familiar with, but generally if you're working in another program, you can get all the output at once. You don't really have a choice. It's like, here's all this crap. But with R, you can save it and say, I only want this piece right now, thanks. Data frames are the way we generally think about data, so it's kind of like having an Excel document. Okay. And if you can't remember all the column names, or if you're like our lab, sometimes the data set has 1,000 column names, it can be difficult to remember everything, right? And so the environment window will let you see most of that. Now it has its limits, and there are ways to look at variable names. There are additional ways to look at them, so it's not your only option, but it's a way to help you remember what you have open. So in a sense, it's kind of like the variable view window in SPSS. Not perfect comparison, but close. And that's where I'm going to end this particular video. I'm going to do a separate one on object types to keep the length of these videos down. So you'll want to watch the second video to look into object types, and we'll go over what are all the things you could store in R.